Namaste student. Today we are going to start a new chapter, that is limit and continuity. So before starting this chapter, we have to know about what is calculus. So calculus is the branch of mathematics which deal with continuous change. That means it deals with the continuous change. There are four basic concepts. First one is limit, another is differential calculus, integral calculus, and multiple calculus, or not multiple, multivariable calculus. So in this class 11, what you will going to see, limit and differential calculus. Under differential calculus, you will going to see the differentiation, means how to find the derivative, or you can say that derivative is the special type of limit. That means we're going to find a special type of limit, and we're going to see the geometrical concept, mathematical concept, and physical concept of derivative. So generally calculus is categorized into two parts. One is differential calculus, which talk about the rate of change, and integral calculus, which talk about the accumulations. Or if we'll say the definite calculus, definite integral calculus, which deal with the curve, area of the curve, or you can say the area under the curve, not area of the curve, area under the curve. That means if I'll take the curve like this and the point A to B like this, then this area is what, how will you going to define? If the curve is fx, then this is the symbol A to B fx dx. This is the symbol for indefinite integration, which we will going to see in class 12. Right now we are going to see that this part, if we take one point and if we take one line through this one, you can see that is touch only one point. We call this line as a tangent, and if we join it or it intersects the x-axis, then you can see that there is an angle, and this angle we call, or we can say the inclination of this tangent we call slope. So this is nothing but a what? To find this one, we need to find the derivative, that is special type of limit for this fx. So generally we use this symbol fx, and we need to find dy dx, which talk about the slope of the line, or you can say the slope of this tangent at a point. This one you say that AB or something, any other point, we say the slope of this tangent at point x1 y1. You can say that x1 y1, we can represent it like this, x1 y1. Then this derivative talking about slope of the tangent. That means if you give a name AB, then there is a slope of AB, which is what? Tan theta. Theta is the inclination of this tangent, or rate of change of y with respect to x. That means sometimes you use dx by dt. I hope you have seen in a physics, dy by dx by dt, or x or s, you use the displacement, then we say that it's a velocity. Or you take sometime dv by dt, where you have seen that is a velocity and it's talk about the acceleration. So, and if you go the mathematical definition, then dy by dx is nothing but limit h tends to 0 f x plus h minus fx by h. So this is a mathematical definition. This talk about your physical definition, and this is geometrical definition. This is whole thing about the differential calculus. We're going to see this one in detail. But the first concept is that limit. What is limit? So because of this not defined part, or you say that indeterminate form. So what is this indeterminate form and what is undefined part? The limit comes. The limit discuss how a function behave near a point instead of that particular point. In mathematics, we encounter functions which are not defined about a point or about a range of value. Like if I'll give a point like x square plus or minus 1 by x plus 1, and if I ask you find the value of this one, f of minus 1, so you put the value here, minus 1 to the power 0 minus 1 by minus 1 plus 1, and you'll get here how many? 0 by 0. See, we are getting something fishy, that is 0 by 0. This is very difficult to get this one, and to get this value, which value? To get this one, we use the concept limit. So after substituting the direct value, we are not getting, and how could you get the value? Actually, limit means word nearest, talking about the neighborhood of a point. That means we'll not exactly take minus 1. We're not going to take exactly minus 1. We'll take the value which is very close to minus 1. That talks about the limit. Okay, so before discussing about the concept of limit, we'll enter into the concept of indeterminate form. What is this? This is indeterminate form. So what is the meaning of indeterminate form? The expression is an indeterminate, or we say that which gives us 0 by 0 is indeterminate form. That means you cannot determine it. See, you cannot say, sir, 1 by 0 is indeterminate or 1 by infinity is indeterminate. Can I say like that? No, we know that 1 by 0 is undefined and 1 by infinity is also undefined. You cannot define. So how could you say that 1 by 0 is undefined? What is the meaning of this one? See, when the fraction comes, we talk about the fraction is what? We break into some part. You take the whole part, you break it. Now we are taking the whole part and we are dividing by 0. That means you are not taking out anything. When you are not taking out anything, you cannot find a value for that. That is totally undefined. And what about this one? Infinity. Infinity is a large value, which is a concept, it's an idea. So when you take 1 by infinity, you cannot say that you will get somewhere we use here 0 also. We're going to use 0. Okay, we're going to take the limiting value. For this one also we'll take 1 by 0 is infinity, we'll write. In physics, in many where you will going to see 1 by 0 equals to infinity and 1 by infinity equals to 0. And we'll also going to use this one. But generally in maths, this is undefined. But when we're going to use the infinite symbol, means limit symbol, not infinite symbol. When we're going to use limit symbol, that means if I write like this, then sir, what will be the value for this? Infinity. And if I'll take x tends to infinity, and if I'll write here x, then what value will I get? That is 0. These are limiting value, remember, not exact. We don't have any exact value for this 1 by 0, 1 by infinity. These are undefined. But what about this indeterminate form? There are 7 indeterminate forms. Let's see, our main topic here is that one, 7 indeterminate form. The first one we're going to see. Okay, well, first I'll write all the 7 form here. That is 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, 1 to the power infinity, 0 to the power 0, infinity to the power 0. So these forms you can see, these all are indeterminate form. So what is the meaning of indeterminate form here? Let's see the difference between 1 by 0 and 1 by infinity. We'll see the difference. They're not equal. Let's see if I take 0 by 0, first form we're going to see 0 by 0. Actually 0 by 0 is the one basic fundamental one, and the rest can be what reduced to this form, 0 by 0 form. Okay, so let's see if I take 0 by 0, that means what I can write like this. I can write here 0 1 ja 0, I'll get this one. If I take 0 0 2 ja 0, yes, so I have what I have, 0 by 0 equals to 1. Here from this result I get 0 by 0 equals to 2. And if I take any one more, that means 0 3 ja 0, that means I can write 0 by 0 equals to 3. And from this 3 also, and so on and so on and so on. From this what I can conclude, 0 by 0 equals to what, 1 equals to 2 equals to 3 and so on. That means 1 equals to 2 equals to 3 and so on, which is totally a contradiction. That means this 0 by 0 have lots of values, not only one, more than one value. So that is what indeterminate means. You cannot determine. You have the value, but you cannot take any one. Lots of value you have. Okay, in undefined means you don't have any value for that. It doesn't exist. But here you have the solution exists, but the solutions are more than one. You cannot take any fixed value. So we can conclude that 0 by 0 is what, indeterminate, as we cannot determine any particular value for this. So similarly, if you go for infinity by infinity, you can reduce it because right now I'm going to use the concept 1 by infinity equals to 0. If I write like that, then I can write like this: infinity 1 by infinity and 1 by infinity, and 1 by infinity means what, 0 by 0. I can conclude. So this reduced to this one. Actually I'm using the concept of what's a limiting value. I'm using here the limiting concept. Similarly, if I'll go for other one, that is 0 by 0. If I'll take 0 by 0, so what we know that a to the power 0 equals to 1. Yes, using this fact, what I can say that using this fact, this I can write that 0 to the power 0 equals to what, 1. I substitute a by 0 and I can write like this. And other concept, power concept, you can apply. 0 to the power 2 is, you can write like 0 into 0 equals to 0. 0 to the power 3, you can write 0 into 0 into 0 equals to 0, and so on. And this conclude that 0 to the power 0 also equals to what, 0. So you can see 0 to the power 0 equals to 1 and 0 to the power 0 equals to 0. From this 2, 1 and 2, I can conclude 0 to the power 0 equals to 0 equals to 1, which means 0 equals to 1. This is again a contradiction. So here also you have two answers. So you cannot determine which one. You have the value, but you don't have the fixed value. You cannot take, and you are getting a contradiction here. So 0 by 0 is also a what, indeterminate form. Let's proceed to another one. 0 into infinity, will reduce it. We can write like this: 0 into 1 by what I can say that okay, not like this. I'll go with the other way. Like if I write 1 by 0 equals to infinity, that is limiting value of 1 by 0 equals to infinity, what I can see, 0 by 0 can be written as 0 into 1 by 0. That means I can write 0 into infinity, which this 0 into infinity is what, again a indeterminate form. So again you can see that this is equals to this, and equivalent, this is equivalent, we can say that, not exactly equal, this is equivalent. So we can see that this is indeterminate, that means this must be indeterminate. see these two concepts we are applying. Limiting concept directly we are applying here from the fact. Another, if we go, that is infinity minus infinity. Sometimes students take infinity minus infinity equals to 0. No, you cannot take. Actually, infinity represents a very large number, but infinity minus infinity doesn't mean that number minus the same number, because infinity does not represent any fixed number. If I take any bigger number, infinity, another also same number, it's not, it's a very large minus another large. There are so many large numbers, so you cannot write infinity minus infinity 0. So that means this may have many values which you cannot determine. So we can conclude infinity minus infinity is indeterminate form. And one more form we're going to see now, that is 1 to the power. We'll take the page. So here there is, I'll go with this one, 1 to the power infinity. Many have a problem with this one. You may say that's a 1 to the power 1 equals to 1, 1 to the power 2 equals to 1, then definitely 1 to the power infinity must have one value. Okay, let us assume that 1 to the power infinity equals to lambda. If lambda is fixed, and if I'll get lambda equals to 1, that means I can conclude, yes, 1 to the power infinity equals to 1. Let's check we are getting the fixed value or not. So use the logarithm on the both sides. What we're going to get here, infinity log 1 equals to log lambda, and we know that logarithm of 1 equals to 0 log lambda. So 0 equals to what you can write, see, is nothing but means here you have 1, so 1 by 0, or not 0, we'll take here 1 by infinity here into log. And now we'll use the limiting concept, that 1 by infinity, as you can see that we'll get 0 log lambda. For lambda equals to 1, for lambda equals to 1, you may get here 0 equals to 0 into log 1, that means 0 into 0, which is true. Yes. For lambda equals to 2, if we'll take 0 equals to 2 into log 2, 0 into log 2, that means we are getting 0, which is also true. Similarly, if we go for the lambda 3, lambda 4, all are true. That means you can say that this is 2, equation 2. That means you can say that equation 2 is true for all lambda equals to 1, 2, 3. And this is your equation 1 you choose. So what you can see that this equation 2 comes from the equation 1, and we have the lambda value, that is 1, 2, 3. So what you can conclude that 1 to the power infinity have 1, 2, 3, like that, different values. Is it possible? Think. So we cannot find the particular value. 1 to the power infinity equals to 1, we cannot write. We have lots of answers. So from there, what we can conclude, that 1 to the power infinity is indeterminate form. Similarly, one more we have, that is infinity to the power 0. It is also indeterminate form. Try to think on this, the last one. And we're going to see this all can be solved, maximum part can be solved using limit concept. We don't have this many in our syllabus, and we'll try to convert each part into 0 by 0, whatever we have. So we have 0 by 0 in our syllabus. So we'll see that part. So in next video you can see that the concept of limit, and then we'll see the evaluation of limit. Okay, thank you student.